I'm sorry.
Oh, it's my fault. I apologize, it's my fault. Well, for the people listening at home, terribly sorry about this. We just studied, we went through the while statement and the break statement. And there'll be assignments on the while and break statement. There are two people missing who asked me to do this, so I'll write up a little bit about them. Sorry about that, folks. All right, so we've got the while statement, we've got the break statement. There's also another statement which I will only show you in the exercises called continue. And what continue does is jump to the top of the loop, the top of a loop again. No, actually, let me show you an example.
I have a question.
Yes, sir. Sorry.
With break. So, break is breaking out of the while loop, but not the if loop.
Oh, well, so that's a very good question, actually, and it's actually easy to make this. Break only breaks you out of loops. If isn't actually a loop. So break only works for for and while. And there's another question you may have is, what if I have nested loops? What if I have a for loop inside a for loop? And you're like, oh, you think now you'd never do it, but no, you do this all the time. Well, the answer is break only jumps you out of the innermost loop. And actually, sometimes that can be annoying. Sometimes you'd like to have break out of everything. There isn't any such thing. It would be tricky. It would make your code trickier. So break only gets you out of loops. It doesn't get you out of conditional statements. And so break only works for the for statement and the while statement. There's also continue statements. You rarely, I'm not going to teach it to you. I'll give it as an exercise. It's just not that exciting. And there we go. What I'd like to do, since we have a few more minutes left, is to go through a little bit through. Oh no! Even before that, I want to go through truthiness and falsiness. As I mentioned before, I was very amused to discover that Colbert uses the same term that Python uses for this. Okay, so we know about true and false. We have these values, true and false, and we know that we can actually do things like if. If true, print hello, else print. I guess I really do need. I guess I can't put it all on one line. We understand. We know about true and false. These two values. They're very good for if statements, and now we know they're good for while statements. Well, one of the things about Python is that it's actually kind of a bit liberal about what you can put in if statements and while statements. So it doesn't. In order for something to be work in an if statement, it doesn't have to be true. The value true. It has to be truthy. What does this mean? Well, let's try the following. If 0, print hello. We get nothing. If I say 0 is a falsy value. 0 is a number that's like false. If I say if 1, print hello, then we actually get hello. In fact, if I do any number at all here except for 0, I get hello. So basically in numbers, 0 is false E, and any other number is true E. So what about lists? And this is definitely, somebody, you have JavaScript experience, right? Marginal. Well, this is one of the things that JavaScript just drives me nuts on. JavaScript does not do this. Basically, in Python, the empty list is false E, and all other lists are true E. So you say, for example, if the empty list, print hello, actually print 1 and stick of typing prints nothing. And if I say, if a list with something in it, it'll actually print the value. That's so totally useful. You do this all the time. One of the things you see people doing when they first start Python is they say things like, they say L equals, L sum list, right? And then, so they say things like, if length L equals 0, print whatever, right? Well, that's we call this unPythonic. This is not Pythonic because it's just much easier to write if, and I'm introducing some new word here, which you haven't seen before, not. If not L, print hello. Or even easier, I can say, basically not the not statement. I probably shouldn't have thrown this in the middle of something. The not statement just takes any false C value and gives you true, or any truthy value and gives you false. So here's an example. Not false. Who's on the spot? What's he going to do? Just take a guess. It should be easy. Not false. Just throw out a guess. Oh no, it's going to print the value of this. Remember, not takes any false C value and makes true out of it. It takes any truthy value and makes false. So this prints true. Not inverts the truthiness or falsiness of the value. Right? So it's very, very useful for negating conditions and doing operations and things. And you can see that we're going to be using use conditions all the time in the if statements, the while statements, and all of those things. So not is actually an operator that has a value here. So let's. I'm going to ask you again, just because I want to make sure I'm not snowing.
Yeah, I really wasn't following.
Okay.
Dealing with Control C.
Oh, okay. Well, no. But so here we go. You know, not the spot. Guess what? Not true gives you.
False.
Yeah. Okay. So let's try the following. Let's try. Now we're going to go to you. Well, let's try what not one. What do you think not one is going to do? Oh, she's right. You missed a turn. Not one is false. Why? Because one is a truthy value. It's not 0. And the not of a truthy value is false. Let's try not 0.
True.
Right, true. What about, let's try not the empty string. John, guess what that's going to do?
False.
True. The empty string is also falsy.
Oh.
You didn't have to know that, that's why it's a guess. You didn't know that yet. So the empty string is also falsy. Yes?
So true and false have to be capitalized?
That is correct. True is just not a variable.
And is there anything else that, has there been anything else that capitalization matters?
Capitalization matters in absolutely everything.
Okay. Oh, it just so happens that everything else is lower.
Everything else would be
Only
lowercase. Only very few things are uppercase.
Okay.
Start with uppercase. And that leads to a very good question. Why are true and false starting with uppercase? I can't tell you the answer to that, actually. Can't tell you the answer to that. What's this?
Yeah.
It makes them pop out.
Yeah, that's
It makes them pop out, I suppose, but you know, why
You would never confuse
Well, because
a true and false condition with, let's say, a true and false variable.
you shouldn't call a variable true.
I understand that, but I'm saying you can't do it.
their class names.
That's why.
That's as good a guess as any. That's a good a guess as any. But anyway, that is a very good question. But yes, in most computer programming languages, upper and lower case is totally significant. I can do things like if I call Tom is 1, 2, 3, and capital Tom is this thing, then there are two separate values. And in fact, Python does use that. Typically, things that start with a capital letter are classes, which you haven't known yet. So you don't know what they are. Typical things that start with a capital letter are generally classes. So, but true and false are not classes. Again, you're not expecting us because you don't know what classes are. But I don't know why they're capitalized. But I can tell you for sure, you'll get it if you put them lowercase. It won't work. All right, so let's go back to that. That's a very good question. And, you know,
all the constants are capitalized.
oh, what's some other constants?
Not implemented, ellipsis.
Whoa, ellipsis.
Yeah, I just.
Oh, none is the other big one.
I just searched why.
That's interesting. Ellipsis. Those are the other ones are very obscure. None you'll find yourself using a lot, actually. But it'll come up in a later lesson. We're learning enough material. None's a special object that has no properties and no methods. It's really handy because often it's very handy because often you want to create a box to do something, and you're later going to try and put an object into it. but you want to start with a value. So you can see, because you may be searching, a classic example is you're searching a list to find some value of the property. Well, but you want something to indicate if that value is not there. So you start off and you say x equals none, and then you search through the list, and at the end you say if x equals none. Oh, wow, I didn't finish that, but yeah. So none is very useful. You use none all the time. Ellipsis, I've never used in like 8 years of Python, ever. And the other one, what was it, not implemented?
Yeah.
Not implemented, I've never used in 8 years of Python. And although you get it, you sometimes get it as a result when you've made a mistake. That's basically it. Frankly, it's just something you use. You'll see it get printed out, and you'll realize, oh, I didn't implement this thing. Don't even worry about this. We won't get another couple of lessons there. Let's get back to where we were with truthiness and falsiness. Okay, so we have not the empty string is false, is true, and also not the other empty string is true. What about who's got? Oh, that's you. Let's try not this string. Notice I'm putting a space between those. What do you
That's
think?
why.
True.
False.
Why does that have a value?
Well, because it's not an empty string. It is a string with one element, which is space.
Oh.
So it doesn't care what's in there. That was a trick question, kind of. It doesn't care. This is exactly the same as saying not to.
Okay. Oh, okay, so it doesn't really
It doesn't care. So it doesn't look at spaces. It doesn't care what spaces are. This sort of thing. It just cares whether the string is empty or not.
Well, I mean, I think it actually is, if we're doing Python for poets, it's actually sort of important that like space is a character. Space at some level, space at some level has a fundamental, as does carriage return.
Absolutely.
Everything is a...
And carriage return actually has the annoying, if you're interested, this is a carriage return character. I hate this part.
It's like a C or something.
Backslash n. You can see, if I do x equals backslash n, I'm just embarrassed to teach you this part, okay? But here we go. If I do print a, look, you see if it actually printed an extra carriage return there. Look at the x, you see the 2 lines there. The backslash, you have to do this, unfortunately, because you can't put a carriage return in your code, because it also means the end of the line. So it turns out there's a whole bunch of these backslashes. Backslash n means new line. N for new line. Get it? And there's, here we go. Who wants to guess what, who's got that? Oh, you do. Guess what backslash t is? Guess what backslash t is?
I have no idea.
Yeah, that's a very good answer. Oh,
I know what it is.
Oh, you know what it is. Tell us.
Tab.
It's a tab character. Yeah. Somebody, I don't remember who it was, but somebody who was involved with this said, the invention of the tab character is one of my all-time biggest mistakes. But it used to be really useful. When we first started doing this, we were printing, you would type on a piece of paper, on a roll. So tabs were useful. If you find a tab character, don't use them. How's that? Don't use them. Actually, they do come in very useful because other people put tabs in their things, and you actually, often I start off by getting rid of all tabs.
Yeah, let's say you're cutting apart pieces of text, and in that text there are tabs. You have to deal with tabs.
Yes, you have to deal with those, but it's unfortunate they exist. All right, talk about discursiveness. Okay, and we're running over time here. I still haven't finished truth and falsiness, and I still have one more tiny part to do with booleans. Okay, so we have now. Let's keep going. We say let's take a look at not the empty list. Who's got? You already answered, right? The last one. So what's going to be not the empty list?
True.
Yes, very true. And how about, I mean, next one is too pathetic, but what's not this list? False. Yes, very straightforward. And so, and this is really, really easy. It means a lot of your conditions are really, really simple, right? For example, let's try, I'll leave this to an exercise. I'm not going to, it basically makes your life much easier. Okay, so now we know truthiness and falsiness. We're going to do one more thing we haven't done before, and this is going to be what's called Boolean operators. And again, sorry for the terminology, logical. Wouldn't that have been a much better way to call it? Logical, but no. We're honoring this long dead mathematician, so we've got to talk about Booleans. Okay, so these Boolean operators, and there are basically 2 of them that you're going to use, and they are OR and they are AND. Well, The two of them are or and and. So let's give it a try. Who's got the thing? Let's say true and true. So these are Boolean operators. Sorry about that. These are Boolean operators. So these are operators that take two values, which are they're a truthy or falsy. Remember, anything in Python is a truthy or falsy, and they return a Boolean value. So guess here. True. True and true is true. Okay, pass this on here. Let's do or. True or true. Guess. What do you think it is?
True.
Right, fantastic. Pass it on. Okay, let's try true and false. Guess. What do you think that does?
False.
False.
Why is that?
No, hey, I'm going to explain it to you, trust me. Okay, well, why is this? Often you want to say something like this. You want to say, if we have x equals 12. So you say, if x is greater than 0 and x is less than 15, print x. So that's what you often want to do. You very, very often want to test two conditions at one time, right? So you want to say, well, if both x is bigger than 0 and x is bigger than 15, print x. You want this condition to evaluate to be false if either x is not bigger than 0 or x is not less than 15. So for the ands to be true, both parts of the and statement have to be true, or truthy at least. Right? So in other words, and, the whole idea behind and is something where you want multiple conditions to be true. You can actually have A and B and C and D. You can put as many of them together. And ands are only true if all of the parts are true. And then so, I think we can hear what's going to come next here. So then let's do, let me just quickly do some more examples. False and false, false and true. We haven't done that one? Yes?
False.
Right? Pass it on. False and false?
True.
No.
False.
False, right? In other words, that would be the case. Well, in this case, it can't happen. But none of the conditions are satisfied. Right? In other words, and all the conditions in an and have to be satisfied. That's the case where you say, oh, I want this person to be a boy, and I want that this field still be alive. Collection of living units. So if you're both dead and a woman, you're completely out of the game. Right? So you're dead and a woman. So false and false is going to be false. And then let's try one slightly more subtle ones. Let's do true or false.
That's going to be true.
That's going to be true. So why is this? Well, the answer is if you're doing conditions where you say, okay, I want somebody who's either alive or male or possibly both. Right? Then it's okay if they're dead, as long as they're male, or it's okay if they're female, as long as they're alive. So you only need one of the conditions to be true in an or statement. So let's go false. This one's so pathetic, but here we go. False or true is true, right? And false or false is
False or false is true.
no, because otherwise it'd be true for everything. It would be a go anyway. No, false is the only time when a result of an or is false is when all the conditions are false.
Okay.
So that's false. Sorry. So basically, false is a way to glue together conditions, any one of which you need satisfied. So if you glue together conditions with an and, all of them have to be satisfied. If you glue together conditions with an or, only one of them or more has to be satisfied. Yes?
Do they do like nans and nors and this sort of stuff?
No. There's other things. So one actually, NAND could be done, you could do that very easy. You can say not true and true, right? And that would be you. Work it out from the center. What's true and true?
True.
True. And what's not true?
False.
False. There we go. It's
I
not
see.
true and true.
So that's
that's the equivalent of a NAND, right?
Right.
Actually, the only one you would want is what's called, you don't have to listen to this, guys. this is a tiny detail, X OR, exclusive OR. Exclusive OR, that's kind of like what exclusive OR is like the English OR. You say, well, either tomorrow it's going to rain or it's going to be sunny. You don't think it's going to bump up. When you say that, you're implying, well, either I'm going to go shopping or I'm going to take a nap. You're sort of implying you're not going to do both. So actual natural English OR is what in computer science terms is called the exclusive OR. You rarely use it in computer science terms. That's why there is no exclusive OR for Python. It's not that common. For conditions. There's, I'm not going to tell you more here because it's too tedious. But what was I going to say? Oh, right. And we're going to do, since we're way over time here, I'm going to do one more thing that's kind of, oh, you have a question? No. One more thing here that's kind of fancy and entertaining. There's two things that correspond. I only thought of this when making up the notes to this. So you see, you can learn a lot by teaching other people this. There are these two really nice, useful operators called any and all that kind of correspond to and or. So here's how they work. Let's just say any of 1, 2, 3. No, let's start off any of 0. No, even better. True, false, false. That's true. That says if, so any is true if any one of the items in that iterable, I made it a list, but it could have been a generator, a tuple, almost anything that gives a value. So any is true if any one of these is true.
True or false or false.
Right, so true, false, false. So the only way any is going to be false is if I say, and the way, one way to say this is, are any of these items truthy? Are any of these items truthy? So I still, Todd, I still think, are you having trouble with this?
No.
Okay, good.
Really?
Good. I see a classic body language thing. Before you were rubbing the back of your neck, and that often means you're kind of like, oh, what's going on here? I'm not, nearly always that works.
I was going to say true on this.
This one, but this one isn't true. This is asking if any of these values are true, and the answer is no, none of these values are true. Right, so any says, so any asks, are any of the values I'm going to get true? And then there's another one called all. So any corresponds to or. Any corresponds to taking your iteration, putting an or between it. And all corresponds to saying all of these. So all, you're on the spot here, right? So all, well, what's this one? Guess what this one is? False. What about all of, of true, false, false? How's that?
Yeah. False.
Right. And of course, the only way to do this is, so nice it lets me, you'll care about that. True, true. That's the only way to do it. Okay. So all is true if all of the operations in that iterable against are true. So all corresponds to and any corresponds to or. Very nice. Now I'm going to add here, we're kind of done, but I'm going to add one tiny detail that we'll run into later, and it's called what's called short circuit execution. And here's the thing is, if I'm going along in my any, pulling out a series of values from any, and I find a true value, I'm done. I don't need to look at the rest of the values. So what any does is it only goes along until it finds a true value. Only if all the values are false does it go to the end. It can be extremely efficient as a result. Because if you find the right value at the first thing, it doesn't even bother to go through the rest of the list. In the same way, all, the moment all finds a false value, it knows that it's not going to make any progress and it's done, so it exits. So this is called short circuit execution. And you can see why. You get to a certain point, okay, I'm not going to do the rest of these. I know the answer, I don't need the rest of these. And one of the reasons you need to know this is because if it's not doing these operations, if you're expecting a side effect from those operations are doing something else, that will not happen. However, this is also true of the and or operations. They do this short circuit, and it's actually very, very common that you use these to say, well, if this condition is true and something else that wouldn't even be reasonable. Like here's an example. enough random examples, let's say the following. Let's say D is a dictionary like 1, 2. Right? So I could say the following. I say if D is not equal to null, and 1 in D. Actually, let's just make this an I. I don't even have to make an if. These can all be some value. So, none. God damn it. Too many languages. Right? So, so here I'm saying that this is the first statement says the following. This D, which is a dictionary, you know it's not none, is none. And 1 is an element in D. So you know, 1 in D, I didn't even show you this before. This is very embarrassing. Very, very useful thing to find out if a key is in a dictionary. Here's my value D. This is a very simple dictionary mapping 1 to 2. So 1 in D, that is true. What about 12 in D? Who's got the
False.
false, right? So it's a great way just to see if something's in a dictionary. Okay? But so, why do I want to go in? So I have this long, complicated thing here. We're almost done here, it'll be 2 seconds. This is the last moment. So I just thought, why am I having this longer, complicated thing? Well, the point is that, gosh, I hate being stupid. Here we go. So that's true. Why am I doing this longer condition? Well, I might say something like D equals none. I may not assign D. Now what I can do is I can run this, and I get the value false, which is what I wanted. What it does is it checks to see that D is not equal to none. Oh, D is none, that's false. It doesn't bother to execute the second half. And why is that? Why is that good? Because if I did 1 in D, I would get an error. Right? So, and I perhaps shouldn't have thrown this in at the end. It wasn't in my lesson plan, but it's very handy there. The advantage of the short circuit execution is if it actually computed both these values, you get an error there. Your program would terminate. You'd be crying. But because of the short circuit execution, it looks and it says, oh, well, D is none. Oh, well then, I'm not even going to continue to evaluate this. That's really, really handy because you can do long things where you say, okay, if it's this and it's this and this, okay, I now know it's a dictionary or whatever it is. What's this?
But how is that an and? I mean, the semantics of it just don't.
Oh no, it absolutely is. How is it? Well, I'll put it this way. Let me put back to you. Why is it not coming out to you as an and?
Because and seems like it's going to have to evaluate multiple conditions, and it's not evaluating.
But no, that's not true. Is if you know that the first part of an and, if you say false and anything at all, you know it's false.
Oh, okay.
That's why.
But it can only it can short circuit to false. It can't short circuit to true.
That is correct. It can't short circuit to true.
Okay.
Or has the reverse property. If the first value to or is true, so if I did this thing where if D equals none or, again that works out perfectly well, right? And you often find yourself doing things like that, whereas that one doesn't work. So in other words, it short circuits when it just knows what the answer is going to be. And in the case of the logical operations, if it runs into a false when it's trying to do an and, anytime it's trying to work out ands, it's like, oh, false, I'm done here. Everything can't be true because I did a false, so I'm done. So short circuit evaluation means you're guaranteeing that it won't go on once it's hit a false or false E value. And that's just so handy. In fact, I don't even have to say, because D here's the thing, is because D, none is false C, of course, right? If you say not none, right? I can actually just say, here in this previous one, D equals none. I can just say not D. Same sort of idea. So you see this in a lot in code. Now, of course, you do have to worry about the following. What's not, this is the empty dictionary here. And what's not this? Who's got the spot? Yeah, it's true. Yeah, it's true. Absolutely right? Or whereas not, D is this. Oh, right. So D, when I make difficult, I can say not 1.2. So, and then not of a non-empty dictionary is false. So you'd have to worry about running into some trap there where in practice it never happens. It turns out that the least surprising saves you. You never run into these sorts of problems. So that was just a tiny thing. Short circuit execution, the thing to remember is we have ands, where if all of the conditions must be true, you glue together booleans, all of them have to be true. or you glue together a bunch of booleans, any one of them has to be true for the whole result to be true. And then corresponding to those, we have any, which corresponds to or, where if any element in an iterable is truthy, then the whole result is true. And all elements in that iterable have to be truthy, and then the result is true. All right, that's a huge amount of, we're going through a great deal of material here. So this is a chance to ask any question, anything. If they're too personal, I won't answer. Nobody's going to ask boxes of print.
I have a bit of code that I would like to know how to make it work.
Okay, well, I'll do that. I'll do it right after everybody else is done.
Well,
Oh, is it very simple?
it's super simple.
Okay, great.
Because
Oh, you probably use Thunderbolt connectors. Damn.
So basically, because when we're doing a lot of stuff, like I'm using print all the time to see what is actually going on, right?
Right, good idea.
So, but I can't do like there's certain situations where if I'm trying to run like length
Right.
or whatever, I can't get the syntax right, so I can't see.
Because it's length is a function, so you have to do. So what you're doing here, you're typing. You're typing here. You're taking print. So you have a list. We'll call it Tom because I'm running out of good names. Right, and you're printing. You're doing print len dot Tom. Like this. That's the default.
That's what I need to do?
No, that's what you're doing, and it's not going to work. You want to print, length is a function. So you want to print length of time.
Okay.
That.
Okay.
Right, so syntax is important. At one point, you don't, when you're in the command line, you don't have to do print anything, you can just type, put the thing's name.
Yeah, I was doing it
In a program.
in programs because then I can
Right, repeat
have
what you
something
do.
to refer
Absolutely.
to, name it,
Definitely.
like experiment with print.
Were you waiting at me?
No, I'm just finding.
All right. I think I exhausted you here. Next week we'll actually get to be running. Well, actually, I'm pretty sure we've covered pretty well everything about the basic language. So in the next lesson, we're actually going to get to write programs that will do something interesting. And this is where I collect money. Thank you for reminding me. I would have forgotten.
The little swipe thing.
I got the swipe thing.
Oh, yeah.
Yes, you can kill it. Thank you so much.